This video will introduce you to Sheet-Cam. Sheet-Cam is used to generate G-code for Mach 3 so that we can cut our parts out. Depending on what options you purchase with your machine, you'll have different types of Sheet-Cam on here. This particular one has two, flat Sheet-Cam and rotary Sheet-Cam. Basically, they're the same program with different post-processors and a few different settings that you will use. I'm going to start with the flat Sheet-Cam. I highly recommend you learn how to cut flat plate before you delve into the rotary. The principles in Sheet-Cam are identical. When you start up Sheet-Cam, first thing you'll see on the left here, we don't have any parts loaded. This is where the parts that we're going to cut are going to be loaded. These are the tools that we have available. We can add more at any moment. These are their operations we're going to perform. There's an excellent help and some good tutorial videos online of Sheet-Cam to delve in further. Most of this is to display what you want to display, and this is mostly to add action tabs and change your start points. To start with, we need to import a drawing. The drawing we generated in CAD of some sort. We provide AutoCAD and Inkscape. If you're free to use another CAD program, if you can save to a DXF or an SVG file. When we open it, it asks us if it's in metric, inch, or custom. It also wants us to answer how we want to import it. As it was drawn, bottom left, center. I typically use bottom left or as it was drawn. A lot depends on what it is. If I drew it with the corner being, bottom left corner being 0, 0, I'll use drawing origin. Use points for drilling, leave that checked because we can use that later to actually just pierce a hole so that we can drill it later on and tap it and get a better quality hole. You can see we have our drawing now. It's a 4-inch square with a 2-inch circle in the center. First thing we want to do is go to create a new jet cutting operation. Now we want to work from the inside out when we're cutting parts. So the first thing we want to cut out is the circle. So that's an inside offset. We want the torch to travel inside of the part. What layer? I named it layer inside. What tool? It'll default to the feed rate here that we had set up for that tool. Maximum chain length is irrelevant on inside, but on outside, if you put that at 1 inch, for example, if any pierces that are within 1 inch of each other, it'll join them automatically so that you can get away with less pierces. On inside offset, obviously, you don't want to do that. You would cut over your part, and Sheet-Cam will not allow you to. Overcut is very handy on circles, and actually quite handy on all things, but as it cuts around, it's going to continue the motion for however long you tell it to overcut, burning where it already has. Leave reverse cut direction checked. That will put the motion in the right direction. Plasma cutting does have a correct and incorrect way of cutting. Path rules we'll cover in a bit. Minimum cut length for DTHC. How long of a feature before you want to turn torch height control on? This is handy if you have a lot of really small holes or really small features and you don't want torch height control on because there's no way the machine can get up to speed. So I have it at 1, so any feature that the overall travel is smaller than 1 unit, which in this case is an inch, it is not going to have torch height control on. Bear in mind that confuses some people because they'll have a 1/2 inch hole and this will be 1. It's the circumference. So a 1/2 inch hole is actually 1.6. So you don't want to get that confused. This is actually the motion that the torch can travel. This is a 2-inch hole, so that's 6.28 inches. So it is going to turn torch height control on. Lead in and lead out is just like it sounds. I'll show you what none looks like. Okay, S1 is start point 1. It's going to start here. Little red arrows indicate what direction it's going. And it's going to cut around. Now we can add some lead ins. Do an arc lead in and an arc lead out. We can vary the size. We can change that to a perpendicular. So now it's going to fire there, move in, cut all the way around, and then curve over, burn for 0.12 of an inch, and then curve out. Once you're satisfied with your lead in and lead out in that cut path, we now want to cut the outside. Same exact operations. We just a few different choices. We're going to do an outside offset, layer outside, same tool, choose OK. You can see that we now have a path on the outside. We can select whatever layer we want to work with, and we can actually click the S and change the starting point to anywhere we want. Once we're happy with that, we click the green P, give it a name. I typically name my G-code files exactly the same name as the DXF files, the drawing files, so that I know they're a match set. Click Save, overwrite it, yes. Running a post-processor, process complete. With no error codes, we have just generated G-code to cut out. And that's the basics of getting started with Sheet-Cam.